Well, hi, good morning, and thanks so much for joining me here in my shop. Today is September 22nd. So, today might be the last day I work on this radio for a while. I may set it aside after today because I have other options, other opportunities to do stuff on my bench, and I really would like to, excuse me, get an output transformer and all that kind of stuff and restore the radio to its natural operation rather than try to use an external amplifier in that. That's going to take some time. So today I think what I want to do is explore the sensitivity of each of the bands and try to figure out what's going on here, because the result, as I understand it, or as I remember it, is really pretty strange. So I've got good sensitivity on the broadcast band, good sensitivity on the 25 meter band, seem to be poor on 19 meters, poor on 31 meters. Not sure what to say about this broadband. Now here's an interesting, what I think is interesting. This is my little note paper where I wrote where I thought the local oscillator was in terms of the target signal. Is the local oscillator running below, or is the local oscillator running above? Pretty sure in most radios it runs above. That's typically where it runs. So in other words, if you're trying to tune in a megahertz, the local oscillator is running at a megahertz plus the IF frequency, so 1460 or something like that. So when I look at my note here, I find in the broadcast band it's below, which is kind of unusual. And on the 31 meter band it's below. And on the 19 meter band it's below. But on the band that appears to be working the best, the 25 meter band or 11 megahertz band, the radio seems quite good. So could I be confused? Yes. So the first thing I want to do is I want to resolve the strength of each of these bands relative to themselves, and do it by pitching a controlled signal from the signal generator at the radio at a certain level, and just go through each band, pick up the signal, and see what the output is, and just find out if that's really the truth, which bands are strong and weak. So really the first thing we got to do is connect the signal generator here. Okay, now the signal generator is not connected directly. I have a little interface box, which is a little hard to see. This box right here, which is a satisfactory, in fact that's an industry standard interface between a test equipment, 50 ohm test equipment, and a 200 or 300 ohm antenna input. So that is taken care of. It should work properly, or work properly at all frequencies too. So we're going from band to band. There shouldn't be a difference in the strength of the output of this signal generator, which I can calibrate also and control. So I should be able to get a pretty good result. Now, another approach here would be to do some, well, I won't even say it. Don't even say that. We don't need another approach. So let's warm this guy up. Okay, that hum was just from this amplifier. And let's go to the broadcast band to start with. And I think maybe at the same time I'm doing this, I should re-verify the position of the local oscillator. Let's just get the radio going first. Now I do not have an external antenna connected. The only thing that's connected to the antenna inputs is my big old signal generator there. Big old signal generator. Big generator. Hey, isn't there a song like called that? Okay. So I'm going to do this with the pointer in the middle of the band the whole time. So I can stick it there. So on the broadcast band we're about 850. And first I want to calibrate my guy here. see if I can do this correctly. So this meter is now measuring output level. The way we do this is we turn this guy down, turn this guy all the way up. This is the control I should be using when I want to just vary the output a little bit. And I should have it set so when this control is max, this meter is reading max scale. That's 10 microvolts. That means there's 10 microvolts here based on this multiplier. So if this is times 10, we have 10 microvolts times 10, we have 100 microvolts here. Exactly what gets to the antenna is disturbed by the circuitry itself. I can't guarantee there's 10 microvolts sitting on the antenna terminals here. But close enough for this kind of work, I think. Let's put this over here. With this control set to the modulation settings, this meter becomes a modulation level meter. And right now it's set to around 40. It's jumping around a bit. It's set at about 30. 30 is typically, 30% modulation is typically what these tests are done with. I'm going to set it to 1000 Hertz. It's just a little easier to hear. So now I've calibrated this guy. We have some idea of what kind of signal strength is getting to the radio. A radio like this, shortwave, if it's a good one, should respond to 10, 15, 20 microvolts of signal. And of course it's not just the signal, it's signal and noise. Here in the shop, hopefully with the signal generator connected, there's not a lot of noise. So, okay, and I'm kind of babbling now. No more babbling. 850, let's tune the signal generator to 850. Just change the lighting here a little bit. 850. Okay, 100 microvolts to the antenna. Volume is there. Volume is very high. This will probably be loud when we come through it. Let's see. I don't think I'm going to get down there. Let's go up this way. It's interesting. That's half. Okay, so we got 836. Get that just as straight as I can. So that looks more like almost 860 here. 836 would be more like that. Now it's quite possible. So it's quite possible that the radio can be aligned at these 2 points and be out in the middle. So we're not going to worry about that right now. What we're worried about is the reading on this meter here. This meter here. Make things a little more visible. And I get my pen. There, we don't need to listen to that tone so loudly. Although look, yes we do. I just changed the volume setting, and of course it's going to change the reading here. I'd much rather do this with the AVC voltage, but we're going to do it this way. So I'm just reading the signal reaching the speaker here. I'll make a little note. So this is broadcast. Once I set this up, I better not change things too much in terms of levels. Okay, so if that's the tone level we want to hear, I got to make my meter a little more sensitive here. It's right on the edge, you know. Okay, we'll go up a little bit. Can tolerate a little bit more of this. Wait a minute. Isn't the volume independent? Oh, it is. Okay, so lucky me. So I'm amplifying the signal that's coming to the meter. If I can turn the amplifier up and down here, it doesn't affect that meter. Excellent, 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 excellent. Lucky break. So I'm going to turn this up, turn the radio up, get kind of a middle of the road reading here. Not quite sure why it jumps around so much. And then we can just turn this up so we can hear it comfortably. I got to put the radio on full supply voltage. I think we're all set. Okay, in my notepad. Oh my gosh, here it is. Here it is, right where it's supposed to be. So we say broadcast band. This is being done at 100 microvolts on the antenna. Broadcast with everything set the way it is. 0.1 volts. So 0.1 volts full scale. 0.1. So we're 0.04, 0.035, 0.035. 0.035 volts. Remember, this isn't actually the voltage going to the speaker. This is the voltage going to the amplifier that's driving the speaker. So it's very low. 0.035 volts. Okay, next band. Now on this band we want to get about just above 9 megahertz here. And I'm just going to pull this back a little bit. Get a little more in the view. Okay. Kind of, yeah, too much stuff. Okay. 9. I should verify the output on the signal generator just briefly. Just give me a moment. Okay, so it's calibrated back on there, and we're aiming for a little above 9. It's pretty quiet in here. I didn't hear a thing. I'm going to work in steps of 10. This is, we'll go up. That's a 10 times stronger signal now. Did I see that meter just fly up there? Huh. Okay, so I don't know why the meter gets thrown over so strongly there. The tone is minimal. So there's some other effect, maybe some DC effect. This meter will respond to DC voltage. Maybe there's a brief DC pulse there of some sort from something, ABC thing. Let me just. Wow, it's extremely sensitive to changes. But that's about the reading. So this is a dB meter, so it doesn't have a 0 down here. So now we're at 0.001. It's really where we are with this. So we'd say the output coming out of the radio on the C band with a 100. Yeah, with 30% and 100 microvolts is 0.001. 1 volts. Okay, next band. Wrong one. Okay, so we're going to pick off just below 9.55. Not far from where we are now. So, hey, exactly the same settings over here. Don't have to check it. 9.5. Oh boy. I didn't hear anything. I'm watching that meter for a jump. Nothing at all. So what I will do, you know what, I made a mistake. This is not 100 now. This was at 1,000 microvolts. At 1,000. So wow, so this is a huge difference between the first two bands we did. Okay, keeping it at 1,000 microvolts. You heard nothing. 10,000 microvolts, 10 millivolts. Below 9.5. There it is. Okay, I'm going to turn it back down. 1,000 microvolts. Nothing whatsoever. Okay, we'll go back up. 10,000 microvolts. So this is band number 31 meters. 10,000 microvolts. And make it come in. We get a 3. 0.03. 0.03. That's similar to the broadcast band, but I've raised the input by a factor of 100. So we hit the broadcast band with 1/100th the signal strength and got the same meter reading, basically. That certainly says something, doesn't it? You know, if every band were equally bad, this wouldn't help at all, would it? I'd end up satisfied with them. So now on this band, we want to go to a little above 11.7. Okay. Let me get in the area here, frequency, and then we'll recalibrate. Oh, I said I want to right by it. So we're at 12.1. Ooh. That must have been an image signal or something. We'll check the calibration here. Way low. Calibrated. 1,000 hertz, 30%. 11.8 or below. And I'm going to knock, well, I'll leave it where it is. This is a sensitive band, so I'm going to knock this down. We are now the same kind of signal strength we used on the broadcast band. Something like that is coming at this radio. Look at that. Let's give it a little volume. Seems like the ABC is a little slow on this radio, but this is good enough. So now we're on the 25 meter band. We're feeding in 10 times, we're feeding in 1,000. 1,000 microvolts. And we're getting get it right now, 0.06 with 1,000. Now that's very similar to the broadcast band sensitivity. So clearly my impression of this was correct. This band is hot. Not the others though. Okay, so we'll go to this top band now. The last guy. Okay. 15.2 something. 15.2 something. Calibration should be okay, but we can check it again. There it is. Check the calibration. We're pretty good here. Here we go, 30%. Okay, so we're sending in a 1,000. This is again 1,000 microvolts. This is the 19 meter band. And the reason we may not, when we had this on an antenna, didn't pick anything up, there may have been nothing there to pick up. That's just too bad. I'm trying to cover that with some tin foil there. And the actual number is 5.05. So what I got here, I've got 3 bands that respond nicely to 1,000 microvolts, and 2 that need a big whopping punch in the head to work. A 31 and a 25. Now let's just double check all this. I want to go back to the broadcast band and make sure it was 1,000 microvolts I was hitting it with. So go back down there. We're in the middle somewhere at 800 something. 800 something. Gotta go here. 800. Somewhere around there. Check the calibrations, way high, way high. Okay, 10 microvolts. 10 times 10, this is 100 microvolts. I'm going to put it to 1,000. 1,000 microvolts heading this way. And we need to hear it now. Wait a minute. Come back. Here until I do that. About 850. Yeah. And turn down the signal strength. So that is a 100. That is 10 times 10, so 100 microvolts. I wrote it down as 1,000 here by accident. So what this says is the broadcast band is very sensitive. 2 other bands are quite sensitive, about 10 times less. And then we have 2 bands that are another 100 times worse. I don't think that's normal. And certainly the shortwave bands I think should all show a similar sensitivity. Something's wrong. Something's wrong. Can it be alignment? Some of these bands, all there is just an oscillator alignment, if I remember correctly, and there's nothing else to align. Could it be something wrong with the setup here? I don't think so, because the pattern is kind of all over the place, isn't it? The lower you go, the more sensitive it is. Is that true? No, because these 2 top bands are showing to be quite sensitive. It's this guy and this guy. 0.01, wait a minute, I'm getting it wrong. 31 and 25. I can't see what I'm doing. 31 and 25. Maybe look at this a little more closely here. There's really only one band that's way off. 31 meter band. Yeah, you know, I'm only showing one band as being way off. I gotta repeat the C band here. I'm writing one thing, thinking another, and saying something else again. Yeah, I think that's probably typical of me. 9 megahertz. You know, I've been hanging around with myself for quite a while. You get to know me after a bit. So let's calibrate. So this is 10 times 10 is 100. This is the same signal you were just listening to, but we're not going to hear it. Let me turn that volume up a little bit. Okay, up by 10. There we are. Band C. So we're at 100 times 10, it's 1,000. It's the same signal as I used before, and I wrote 0.001. There you are. It's pretty well 0.001. So that is correct. So let me. So this is one. So okay. So the way to interpret this band is 1/10 the sensitivity of the typical sensitivity. I'm gonna declare the three of them that are working kind of the same. That's what it should be. 1,000 microvolts at the antenna should give you about 0.05 volts on here. And that's true for three of the bands. And we have the one we're on right now, C band. We're at 1,000. 0.01. So on the other bands, this meter is up about here for the same input. Except on the 31 meter band. So the C band, the 25 meter band, let's go to the 25 meter band, see if we can get the same result, basically, with these levels. 11. Turn the volume up here a bit. Can't get there. So volume is up. Don't be fooled by the volume. Let's hold up this meter. So we're getting roughly the same thing. I'm double checking everything I'm doing here. And then on the 19 meter band, somewhat, well, listen to it. It's receiving. We should get the same sort of effect on this meter when I go past 15.2. Okay, about the same. Good, so that verifies it. So the 31 meter band, last test, 31 meter band seems to be the only band that's really bad on here, really bad. 31. And bop, silence, eh? So 9.55 just below. Right down here. Hello, hello. Turn up the volume. It's not even present. Now if I crank this up by a factor of 10, we can probably hear it. Watch the meter. I can't even, oh, it's just a trick of my eyes there. Well, that's a little odd. It's very, very subtle, but this meter went up a touch, and then as I tuned further I came to the tone. Let me turn it up a little higher. Can't even see it on the meter, but up here there's a little tiny bump. Okay, so that is at 10,000. This is 10,000. 10,000. I got 0.03 on here. I can't even get there. Calibration's off. Check the calibration. Yes, calibration low. Right up. Calibrated now. Now we check. Whoa, that's pretty loud. Volume down. I'm sure there's AVC involved in this. So we're going to vernier that downwards and see what happens. But this is now 10,000, just like I wrote, 10,000 microvolts, giving us a center reading. But the volume seems quite loud. Oh, it's this. That's why the volume. Don't be fooled by the volume. Jim, I just said that. So there we are. 31 meter band's a sick puppy. Everything else looks pretty good. 31 meter band. So there's something about the 31 meter band. And that's a really important band, 9 megahertz. If you're going to listen to shortwave, you want this working for sure. I think maybe just I'm going to make it easy on myself today. I think what I'm going to do is switch to an antenna, run through the different bands, just listen to them, and sort of get a feel. I mean, we should be able to hear atmospheric kind of noise on all the bands if things are working well. And I'll bet you on the 31 meter band we will hear absolutely nothing. Just Total silence. Here we go. I may have to run through my house and make sure the antenna switch is thrown in favor of here. Let's go to the broadcast band. Volume.
The stores closing down, but honestly, I think I have more tea at home anyway. I think that a lot of people drink their tea at home and all time they
Okay, I'm just going to make sure the antenna switch is thrown correctly.
Sorry, Chris, I'm sorry. Is that rude in the workplace? Is that something you mean, boss? I'm not a boss, so we're on equal footing, so
it's
you can't hold it against me.
I'm sorry.
Is it? I'm sorry. Chris, I'm sorry.
I need a tea.
I'm just joking. Hey, we're going to get an update on the contract, let me try this again, on the contract talk with Ford Motor Company in Unifor today at 11 o'clock, so in 15 minutes time. Jerry Diaz and the Feds are proposing $500 million from the Feds to, and I know the province is going to take in some money, to support a refuel of the Oakville Ford plant to build EVs. We're going to talk about electric vehicles with Tim.
Hey, damn, the volume control still works here too. So the deal is the antenna is connected to the radio right now. The switch was in the right position, but I actually have 3 outdoor antennas, and it's just on one of them. I'm not going to switch through and try to find a better version of my outdoor antennas for this. Good enough. So hey, it's working, right? That's what we want to know. So now, according to my sheet here, they're all working except for 31 meter band. So let's just go through them. That's pretty quiet. So I am going to crank up the volume. That's as quiet as can be. Let me boost it over here a little bit. Not impressive at all. Okay, let's go tuning here. So you would hope to hear some kind of hiss. I would anyway. There's a little bit there. So there does seem to be like a sensitive area right in here. You can start to hear the atmospheric sounds. Okay, that's a weird thing. That's weird. That's something in this radio, I think. Just the way it kind of clicks in there. And then just below that, it's sensitive. Not bad. Then rolls right off. Still get this station, but this is a whopper powerful station here.
Time calculation is not going to talk about the calendar because it's assumed
they can pick this up with a radio that's not even turned on. That's how strong that is. And then there'll be nothing down here. There's nothing to pick up at this time of day anyway, so. Okay, so that's that band. Next band. Dead guy. This time of day, there's a good chance of picking up stuff here. Silent, just as I would kind of think. And if we help him out, we just hear the hum of the radio. Probably the capacitor that I put in by the volume control and didn't shield is probably what we're listening to. Nobody home there. Just as I thought. Next band. Next band.
De la ya sin exageración millones de cubanos que están sufriendo esta situación en Cuba. Yo creo que La Habana.
Cuba. And there we can see, you can hear the atmospheric noise all the way through here. Okay, next band, last band, and you can still hear the atmospheric noise, or some kind of noise. Noise on the antenna, dropping out down here. Getting a strong reaction here, right in here. I hear a voice. Something there. Okay, so all this testing has verified the fact that one band is tired on this radio, and the other ones seem to be okay. Now, could a tube be causing that? I don't think so, because if a tube couldn't handle the higher frequencies, then the highest bands would be dead, and it would be progressively weaker as you went up in frequency. So the fact that it's kind of a band in the middle means there's got to be some kind of issue with that band's circuitry of some sort. The last thing we can do, let's see if the Magic Eye has any magic in it. And then I think that's going to be it for this radio for a while. And lots of other interesting things to work on. As I mentioned, this is my own radio, so I can take my time with it. I have the cabinet virtually ready. I'm just putting this camera right in place here, so we can stare into that Magic Eye. Better block out some light. Hey, where's the eye? There it is. It's kind of an odd spot to put an eye when you first think about it, right behind the dial like this, but in fact it's not that odd because you have your eyes on the dial while you're tuning the radio. I'll focus this in a second. I just want to make sure I got a good angle to see it. You have your eye on the dial while you're tuning, and so your eye can pick up the magic here. What do I have to do? I have to focus this guy. Okay. 1 second. Clicking away on my computer. Okay, we'll bring him into focus now. You see the Magic Eye has some pretty interesting, like it's not like a flat green light. It's see the shapes inside there? I don't know how else to say it. They all do that. Looks like I don't know what it looks like. It looks like successive shorelines or something. Now we're going to tune the radio around and see what happens. So I'm going to go on a band where there's stuff to hear. This is the 25 meter band, and we're going to come across those rather powerful, those guys. Looking for any amount of movement in the Magic Eye now. Yep, there's a little bit. It's slow.
Señores, ¿qué va a pasar mañana? Me pregunto, ¿no va a pasar nada en el próximo mes? En los próximos 2 meses, ¿ustedes creen que no se va a caer otro edificio? De lo que yo les estoy leyendo, prácticamente cada 10 días en Cuba hay de estos derrumbes.
You'd think that'd be a strong enough signal to trigger it. We're gonna slam the radio with a really strong one soon. So that's not very impressive. Now let's slam the radio. So what I'll do is I'll put the pointer right here. That's a little bit below 11.8 megahertz. I will put the signal generator up there. There we go. I disconnected the signal generator. Okay, we're going to come off the antenna. What I'm going to try to force the eye closed with a powerful signal and see what kind of signal it takes to do it. Okay, that's the signal generator on. And we're right around 11.8. Here we go. I mean, I'm blasting this radio. I'm giving it 10,000 microvolts, and the earlier tests were done with 1,000 microvolts, so it's 10 times the signal. And there's nothing going on with the eye. Whoops, I bumped the camera here. A little wee bit. So that raises some interesting questions. And this might be part of the whole picture too. Let me just switch back here. So what's that mean? Is the eye not working? I think the eye is probably working. It's dull, but it's probably functioning. And why is it not closing much? It's not getting much AVC voltage to operate with. Why is that? Well, now there's a long list of possibilities. Is this radio operating without the benefit of AVC? So we can try another band with something on it. Which one was that? It wasn't that one. There was no other band with anything on it, really. Even the broadcast band was pretty darn weak. It's fun switching bands on here. And I'm looking at the eye, and I know you can't see it now, but so there's powerful noise signals. You can see the other meter just going wild over there. But I can see the eye is not moving. So I think that's another issue with this radio. For the AVC is not really working anywhere. So 1 weak band, AVC not responding, eye not showing any action. Otherwise, it's coming along, There we go. Okay, so I think that's it. That's it for now. I am going to put this radio away, not too far away, and I'm going to carry on with some other projects in here. In the meantime, I am working at getting another output transformer for it. I've also went into detail, but I think I'm about to score another 1,000 vacuum tubes or so, and in there I already know there's at least one 6F6 in there. So perhaps we can even get back to having the proper tubes in here and get away from the 6V6s that are in there. But I'm going to take a little bit of time. So I think that's it for now. Unfortunately, I hate to stop projects, but sometimes you just have to do it for various reasons. So thanks a lot for watching to this point, and I'm kind of happy with the situation because I'm getting somewhere, and I'm pretty happy with the cabinet. It turns out to be pretty nice looking. It's actually a nice looking radio. $20, very good. Okay, so I'll see you on the next video, and enjoy your day.